Hello, and welcome to the Earth Layers Project. In this video, I will be providing everything you need to know about the layers of the Earth, such as the 6 layers, composure, density, melting point, thickness, and more. The Earth has 6 layers such as the crust, mantle, outer core, inner core, lithosphere, and asthenosphere. These layers range in thickness and size. I will put them in order from thinnest to thickest. Crust is the Earth's thinnest layer, ranging from 5 through 40 kilometers thick. The crust is located just above the lithosphere. This layer is mainly composed of granite and basalt along with other igneous rocks. This layer is around 900 degrees Fahrenheit and has a density of 2.83 through 3 grams centimeters cubed. The pressure of the crust is around 4 GPa. This layer is in a solid state of matter and the melting point of the crust is roughly 1000 Kelvin. The lithosphere is the Earth's second thinnest layer and is approximately 100 kilometers thick. The lithosphere makes up the crust and some of the upper mantle. It is located just above the asthenosphere. The lithosphere is mainly composed of crustal material. The temperature of this layer is roughly 932 degrees Fahrenheit. The pressure of this layer is 18 GPa and the density is around 2.7 through 3 grams centimeters cubed. Along with the crust, the lithosphere is also in a solid state of matter. The lithosphere has the same melting point as the crust at around 1000 Kelvin. The asthenosphere is the Earth's third thinnest layer and is approximately 180 kilometers thick. The asthenosphere is located in the upper mantle directly below the lithosphere. This layer is composed of semi-plastic rock. The temperature of this layer is 2,336 degrees Fahrenheit and its density is 2.7 through 3.3 grams centimeters cubed. The pressure of this layer is roughly 100 GPa. This layer is mostly solid but may be molten in some areas. The melting point of the asthenosphere is roughly 1001 through 4850 Kelvin. The mantle is the Earth's fourth thinnest layer and ranges from 100 through 200 kilometers thick and in some spots 400 kilometers. The mantle is located directly beneath the asthenosphere. This layer is mainly composed of silicate rocks with iron and magnesium. This layer has temperatures ranging from 1832 through 6692 degrees Fahrenheit. This layer's pressure is 136 GPa and its density is 3.3 to 5.5 grams centimeter cubed. This mantle is solid, but as you reach the boundary of the outer core, it may be molten. The melting point of the mantle is approximately 1001 through 4850 Kelvin. The inner core is the Earth's fifth thinnest layer and is around 1200 kilometers thick. The inner core is the center core of the Earth containing temperatures of 5,200 degrees Celsius or 9,392 degrees Fahrenheit. The inner core is composed of nickel and iron. It's solid metal. This layer has the hottest temperatures at 9,932 degrees Fahrenheit. The density of this layer is about 11.5 to 12 grams centimeters cubed, and the pressure is 330 GPa. The outer core is in a liquid state of matter and has a melting point of 4,851 Kelvin and drops down to 2,250 Kelvin and enters the core at 2,800 Kelvin. The outer core is the thickest layer of the Earth at 2,250 kilometers thick. It is the layer above the inner core of the Earth. The outer core is made up of molten metal or formerly known as magma. This layer has a temperature of around 8,132 degrees Fahrenheit. The density of this layer is 9.5 to 11.5 grams centimeter cubed, while the pressure is 135 through 300 GPa. The inner core is almost pure metal and has a melting temperature of 2,500 through 3,000 Kelvin. I will now move away from the layers of the Earth and discuss the magnetic field. The magnetic field or magnetosphere is a layer of charged particles that extends 10,000 plus kilometers out into space. The magnetosphere is directly caused by solar wind meeting the magnetic field of the Earth. The magnetosphere protects the Earth from intense solar particle radiation. It also helps maintain the atmosphere from charged particles such as solar wind. Without this layer, radiation would bombard the Earth. Solar radiation is extremely harmful to life, which makes the magnetosphere vital. The Earth has 7 major plates: the North American, South American, Antarctic, African, Pacific, Eurasian, and Australian plate. The plates are constantly moving at an average of 4 inches a year. The North American plate is moving southwest at roughly 1 inch yearly. The South American plate is moving westward a little more than an inch yearly. The Pacific plate is moving 3 to 4 inches northwest each year. The Australian plate is moving roughly 2.5 inches northeast each year. The Eurasian plate is moving a quarter inch southwest yearly. The Antarctic plate is moving half an inch southwest yearly. Last but not least, I will show how constructive and destructive forces change landforms. Here are some sand dunes. Notice how the sand is loose. Therefore, wind can destroy dunes and create new dunes. In this case, wind was acting as both a constructive and destructive force. But that's not always prominent. Let's look at another example. Here is a newly forming Hawaiian island. As lava meets sea, it cools and hardens, forming more land. In this case, lava is a constructive force adding onto and building the island. A destructive force wearing away the rock of the island would be the ocean. Waves pound against the rock, weathering and eroding it. For my last example, I will use a mountain. A possible destructive force in this scenario would be rain. As it rains, the mountain is weathered and eroded, over time making the mountain a hill. A constructive force could be plate tectonics. As plates collide, it could continue to build up and heighten the mountain. That will conclude the video. See you in the next one. Bye.